Hello again. So this is assessment problem 4.10, in which we have to use the mesh current method to find the power dissipated in the 2 ohm resistor. Okay, so in order to use the mesh current method, first of all we have to locate all the meshes in a circuit. So here we have 3 meshes, 1, 2 and 3. So let me call this as mesh number 1, this is 2 and this is 3. So this is the first step. After allocating or seeing at different meshes here, let me allocate a supposed current in each mesh. So in mesh number 1 I am supposing a current I1 here, which is in the clockwise direction. Similarly, in the mesh number 2, let me suppose the current I2, and in 3 let me suppose the current I3. Okay, so these are 3 meshes, and each mesh we have to find the value of I1, I2 and I3. Here we can also see that in mesh number 3 we have a current source here in the last branch. So we can see here that the only current which is flowing through this branch is the I3, which is in this direction. If we supposed it in the clockwise direction, so the I3 is flowing in this branch in the opposite direction as that of the source current. So here in mesh number 3 we have seen that the value of I3 is already known, and the value of I3 is basically the minus 16 amps, and this minus is because of the direction of our supposed current. Okay, so the value of I3 is already known. So let me now solve for the I1, and for I1 I have to use the mesh number 1, and in mesh number 1 I will again apply KVL. So by using the KVL here, V30 is equal to the V3 plus V6 plus V2. Okay, so now writing their values here, the value of V30 is the 30 volts, and this is the voltage rise. As we have seen in the earlier questions, we are using the same rule which we have allocated for our circuit analysis problem. Similarly, the current which is flowing through 3 ohm is the I1, the current which is flowing through the 6 is again I1, and the value of the current which is flowing through 2 ohm resistor is basically I1 and I3 both. As we are in mesh number 1, so we will take I1 as a positive and I2 as negative. Okay, now rearranging them, it will become 30 and 3I1 plus 6I1 plus 2I2 and minus this is plus 2I1 minus 2I2. okay, so it will become 30 equal to, adding all the terms which involve I1, so I will get the 11I1 and minus 2I2. so let me call it equation number 1. okay, so this is my equation number 1. Similarly, now moving towards the mesh number 2 here, and again applying the KVL here, we will see that the value at V2 plus V8 plus V5 plus V4, this is equal to 0. Now putting their values here, this is the resistor which is shared by the mesh 2 and 1, so the values here will be 2, and now we are in mesh number 2, so we will take the current here is positive and I1 as negative. As we can see here that here when we were in the mesh number 1 we took I1 positive and I2 negative. Now we are in mesh number 2, we will take I2 positive. This is the supposition, and this is because we are taking the polarity like this one, and if we are in this mesh we are taking it the voltage drop, so polarity will be like this one. If we were here we would have taken it like this one, and therefore we took I1 as positive. Okay, so that is the reason here. So now V8 is equal to the 8 I2, V5 is equal to the 5 I2 minus I3, and similarly the value of V4 is plus 4 I2, and the sum of it is equal to 0. Okay, so now this would become 2 I2 minus 2 I1 plus 8 I2 plus 5 I2 minus 5 I3 plus 4 I2. This is equal to 0. Writing the value of I3, which is the minus 16. So first adding all the terms of which relates basically I2. So I2 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 and I2. So 2 plus 8, 10, 15, and then 19. Okay, so minus 2 I1 plus 19 I2, and here minus 5 multiplied by minus 16, this is equal to 0. And now minus 2 I1 plus 19 I2, moving it to the other side, we will get it 5 minus 16, which will ultimately give me minus 2 I1 plus 19 I2 equal to the minus 80. So this is my equation number 2. So now we have two equations, and we have to solve them here. So as in equation number 1 we have 11 I1 and minus 2 I2, and in equation number 2 we have minus 2 I1 plus 19 I2. So now we have these two equations, and solving by the conventional methods, we have to multiply the equation number 1 with 2, and then we have to multiply the equation number 2 with 11, and then at the end we have to add them together. So when I will multiply 2 with the equation number 1, I will get the 22 I1 minus 4 I2 is equal to the 60, and multiplying 11 here at both sides, I will get minus 22 I1 and plus 11 multiplied by 19 is 209 I2, and similarly 11 multiplied by 80 is minus 880. Okay, so now adding them together, these two will cancel out, and here we will get 205 I2, and it will be 820, or the value of I2 here will be equal to the 820 by 205, which will be equal to sorry, this is the minus, so it will be equal to the minus 4 ampere. So this is the value of I2. Similarly, now taking it and putting in equation number 1, okay, we will use it as 11 I1 minus 2 minus 4, okay, equal to 30. So 11 I1 plus 8 equal to 30, or I1, the value of I1 will be equal to the 22 divided by 11, and that would be equal to the 2 amps. So we have known the two values which have to be found in this equation. Now we have to find out the value of the power which is dissipated in the 2 ohm resistor. So the P2 is equal to I square into 2, which is R, basically I square R. So what is the value of current here? That is basically the I1 minus I2 whole square multiplied by 2. Writing values here, we know that the value of I1 here is basically the 2 amperes. Similarly, the value of I2 is the -4, okay, and it is 2. So now 4 plus 2 is 6, okay, 6 square multiplied by 2, this would be 36 multiplied by 2, and ultimately we will get 72 watts. So this is the answer which we were looking in this question, which we were looking for in this question. So that is the end of this question 4.10, and we have seen in this question that how to use the mesh current method to simplify the questions in which the branch current is given. And we can see here that as one branch current is given here in our mesh number 3, so it has basically simplified the question in which we were looking for the power dissipation in any resistor. So I think it's enough, and it has clarified your concept related to the mesh current method. So I will see you in the next video. Thank you so much. Till then.